a lot. Okay, so let's check out number 35. Find the domain and range of the relation, and then we're also going to figure out whether or not it is a function. So what is the domain here?
All the x intercepts.
All the x coordinates. Good. So what would that be?
2, -8, and 1.
Good. And you are correct that you do not have to worry about putting them in numerical order. In fact, I would not mess with that because you might make a mistake and lose a negative or something and get the problem wrong for kind of no reason. So just go ahead and copy them down in the order they're in and you're fine. I mean, you obviously are allowed to put them in order, but you don't have to.
Okay.
What about the range?
The range would just be a -9.
Good. And you do not write it. So the set notation is interesting. It has some interesting rules. One rule is the order does not matter. But another rule is that if a number shows up more than once, you only list it once. So it is important that you only put one -9 there, not 3 -9s. Okay. Is this a function?
Yes.
Yes. How do you know it's a function?
The x's don't repeat. Yeah.
Exactly. The x's don't repeat. Also, let me tie it into what we are about to do on the next page. Let's look at a graph real quick of these ordered pairs. Oh, I should have drawn this lower because they're all down here. Okay. So 1, we'll pretend this is -9. Use our imagination. 1, -9, 2, -9. Then over here, this is -8. I know you all believe me. So those are our 3 ordered pairs, right?
Mm-hmm.
It's a little bit of a loose sketch, but that's okay. What test can you use visually to see if you have a function?
Vertical.
I think one of you said it, but I was talking over you.
Yeah, the vertical line test.
The vertical line test. Good. So the vertical line test says if any vertical line that you draw crosses the graph at most once, then you're fine, right? So here, any vertical line that you draw only ever crosses through one point. So that would be another way to know this is a function. Whereas if you had 2 points, let's say you also had the point 1, -8, which would be like right here, right? It would have that repeating x coordinate, which would make it not a function, but it would also fail the vertical line test, right? If that was the point, like 1, -8, for example. Okay, so we're good with that?
Yeah.
Okay, so let's look at number 37.
Not a function.
Not a function. Why not? What ordered pairs are giving us trouble here?
The like 1 and -3 and then 1 and 1.
Very good, because if you draw that vertical line x = 1, it goes through both of those ordered pairs, which makes it not a function. Excellent. What about number 39?
It's a function.
That's a function. Good, because any vertical line that you draw only crosses it once. Yep, so that is a function. I agree with you guys. What about number 40? Is that a function?
No.
No, because any point that you draw that kind of goes through the circle automatically crosses it twice. So no. Okay, we're actually doing pretty well with time, so I'll keep adding a few problems back. Let's try number 41. How would you find f of -2?
You plug -2 in for x anywhere in the equation.
Very good. And the negative and 2 are attached to each other, so you're squaring them together. So you're doing -2 times -2, which is a double negative, so it actually becomes +4.
Yes.
And then 4 plus 4?
8.
Is 8. So your answer there would be 8. Okay, so see if you can work out F of 0 and F of 3 for me. So what did you get for F of 0?
4.
Good. And for F of 3?
Got 13.
Good. 13 is correct. So let's make it a little bit harder. Number 43. What makes number 43 a little bit harder than number 41?
There's a another coefficient in front of x.
Very good. Nice vocabulary. There's a coefficient in front of the x squared. So that will be an extra step. So when you work it out, I'm going to write it out, but then what do you do first?
The exponent. So you have to do -2 times -2.
Good. Why do you do the exponent first? You're correct, but why?
Well, because that's what like for PEMDAS, that's what it is.
Exactly. So we're actually using PEMDAS here. Very good. Parentheses, exponent, and then I like to write multiply, divide next to each other because you do them in order from left to right. Addition, subtraction, you do in order from left to right. But yes, so P stands for parentheses, which means anything that can be simplified inside parentheses. It doesn't necessarily mean eliminate all your parentheses first, but it means if there's an expression in parentheses. Then you would do exponents, which is the first thing that we have here, because here the -2 is already simplified inside the parentheses. So your first step would be deal with the exponent. Then you're going to multiply or divide from left to right, and then you're going to add or subtract from left to right. Both of those you do from left to right. So here you have to deal with the exponent because the 2 out front is being multiplied. So that's a step that comes later. Okay, so -2 when you square it becomes what?
4.
4, which I think you had already said. And then we have to multiply that by 2 next, right? Because we have to do any multiplication or division before the addition or subtraction. So what is 2 times 4?
8.
And then 8 plus 2? 10. Good. So why don't you guys go ahead and try parts B and C again. H of 0 and H of 3. So what did you get for H of 0?
2.
What did I just do? I have no idea. Okay. So let's be careful there. The first step is 0 squared, which is
0.
0. 0 times 2 is
0.
And then 0 plus 2 gives us a final answer of
2.
2. Good. And then what do you get when you plug in 3?
I got 20.
Yeah.
Okay, let's see. You do 3 squared first, which is 9. Good. 2 times 9 is 18. 18 plus 2 is 20. Very good. I agree with you. With both of you. Okay, so let's move on to the next concept. Number 45. For the function value f of -8 equals -3, write a corresponding ordered pair. So keep in mind that an ordered pair is x, y, right? So you're going to use the numbers -8 and -3. Which one is going to be your x and which one will be your y?
-8 will be your x, and then -3 will be your y.
Very good, because x is your input. So -8 is the number you're plugging into the function. -3 is your answer, so that makes it the ordered pair -8, -3. Just like if we go back to the problems we were just doing, right? We plugged in 0 and we got 2. So the answer to the problem was 2, but if you had to write an ordered pair, right, this would be the ordered pair 0, 2, and this would be the ordered pair 3, 20.
Mhm.
That's not how they asked for the answer in that problem, but that's the ordered pair that would be represented on the graph, right? So now that is what they're asking for down here. Okay?
Mhm.
So now we're going to look at domain. For domain, as long as you have a polynomial, which by that I mean x is in the numerator, not the denominator. X could have an exponent, so it could have a squared or a cubed or something like that. X can have a coefficient, like in this case, it has a -9, and there can be a string of those added together, right? Those are polynomials. When it's like x to a power with a coefficient added or subtracted to something else that looks the same, x to a power with coefficient, et cetera, et cetera. Okay, anything like that, the domain is automatically going to be -infinity to infinity. So that works for any polynomial. The reason is you can plug in any number that you want for x because it is possible to multiply any number by -9 and then add 3 to it, right? Or whatever the polynomial is. So as long as you recognize that it's a polynomial, it's going to be -infinity to infinity. There's no work to be done there. But number 47 is different. What's different about number 47 compared to number 46?
X is in the denominator.
X is in the denominator. Very good. And we talked about it earlier today, actually. What is your denominator not allowed to equal? What gives you trouble?
0. It can't equal 0.
Right, because if a denominator equals 0, then we say it's undefined, right? And in order to be in the domain of a function, it means that when you plug in that number, you get a real answer out of it. So getting undefined is not a real answer. So therefore, we need to make sure that our denominator does not equal 0, right? So that works for any fraction, no matter what it is. We have to say, okay, our denominator, which in this case is x plus 9, cannot equal 0. So what does that mean x is not allowed to equal?
0.
X could actually be 0, right?
Oh.
Because 0 plus 9 is 9. So that would be fine. How could you solve for x here? How could you get the x
Oh,
by
you'd
itself?
subtract the 9.
Very good. So x actually cannot equal
The negative.
-9. Then they're asking, is there a question?
Well, this is where they use like the union symbol.
Yes.
Mm.
So the way to think about this, which is a little bit tricky, in the last problem, if you were looking at a number line of all the possible x's, you would be shading it all in, right? Any x's would work. Here, what's going on, because this is a reference to what you guys did, we looked at number lines last time, and I remember, so I know you saw number lines in the first module. X cannot equal -9, so it would be at -9. Your course uses the parentheses and brackets, right?
Mm-hmm.
Okay, so at -9, it would be like you had parentheses facing both directions. Like it's not allowed to equal -9, but it's everything else.
Yeah.
So then, yes, you're going to have to use a union symbol to list what's on the left and what's on the right. So on the left, of course, forever left is always -infinity. Forever right is always +infinity. So how would you write out this answer?
It would be like parenthesis -infinity, comma, -9, infinity, and then the u, and then parenthesis -9, comma, infinity.
Good. And with the infinity symbols, either the negative or positive, we always use parentheses, right? Because you can't touch infinity. You can't equal infinity.
Yeah.
And whatever the number is that you're excluding always goes in both spots. And you have to use parentheses for it because you're excluding it. You're saying that you cannot equal it. So that's why you have to use the parentheses and not the brackets. And the union just indicates that you have two sets that together form your answer. or two intervals that together form your answer. Okay, and there should be a union symbol that you're using, so you're not just typing in the letter U. There's actually a union symbol on your keyboard, I believe. Not on your, physical keyboard, but on the screen, there's an option.
Yeah.
Okay. How about number 48? How do we find the domain from the graph? What is the domain looking at on the graph?
Negative infinity to positive infinity.
So here it would be that, because your domain is always looking at your x values from left to right. So I agree with you, Caitlin, that if you follow the graph here, it's going up, but it's also going forever left. If you follow the graph here, it's going forever right, and there's no gaps in the middle. So I agree with you that your domain is going to be negative infinity to infinity. And once again, anytime you use infinity symbols, you're going to be using parentheses. What about the range? Now we're not looking at the x values. We're going to look at the y values. And you always have to go in numerical order, smallest to largest. So I like to say that you look at the y values from the bottom to the top, because you have to go from the negatives to the positives. So what is the lowest? So just looking at the graph visually before you even figure out the range, what is the lowest ordered pair on the graph?
2, 2.
Good. Okay, and then for the range, you're looking at the y value. So you would be interested in this right here, the 2. And then what is the highest point? How far can we go up on the graph?
Infinity.
Infinity, good. And then what symbols would we use? Parentheses or brackets, or what would we do?
Bracket, and then a parentheses by the infinity.
Good, so always parentheses with the infinities, and then with the 2 would be a bracket, because there was actually an ordered pair there on the graph. Good.